Hello everyone and welcome back to my channel for a new technology video. The today's argument is space rockets, or if we want to be more precise, orbital launch vehicles. In the world there are really many of them, so in this video we will take into consideration only the one with a low Earth orbit payload above the 10,000 kilograms. We started this list with the GSLV Mark III from India. We had the first launch in 2017 and the latest one in 2019. Until now we had 4 launches and all of them successful. For this rocket we have a cost of $51 million per launch, with a maximum payload of 10,000 kg in low Earth orbit or 4,000 kg for geostationary transfer orbit. The launcher has a weight of 640 tons, an height of 43.4 meters, a diameter of 4 meters and a width of 10.4 meters. We can find 2 plus stages. As a first stage we can find 2 boosters and a core stage. The 2 boosters have a weight of 236 tons with a height of 25 meters and a diameter of 3.2 meters. For the engines we can find one S200 is a solid booster with a maximum thrust of 5.2 MN at sea level, and the burn time of the boosters is 128 seconds. The main core stage it has a weight of 125 tons, an height of 21.4 meters and a diameter of 4 meters. Here we can find 2 engines, this time they are liquid engines, with a maximum thrust at sea level of 1.6 MN. The burn time is 203 seconds. After the disconnection of the main boosters and the first stage, we can find the second stage. This one has a mass of 33 tons, an height of 13.5 meters and a diameter of 4 meters. Here we have just one engine, liquid, with a maximum thrust of 200 kN in vacuum. The burn time is 643 seconds. At the end we can find the fairings that contain the payload. They have an height of 8.5 meters and a diameter of 5 meters. At the 9th spot we can find the Long March 3B from China. We had the first launch in 2007 and the latest one in 2020, with 59 total launches. 57 of them were a success, then we had one failure and one partial failure. Each launch has a cost of $75 million, with a payload of 11,500 kg in low Earth orbit, 5,500 kg in geostationary transfer orbit, and 3,300 kg in heliocentric orbit. The launcher has a mass of 458.9 tons, an height of 56.3 meters, a diameter of 3.5 meters and a width of 8.2 meters. In this case we can find 3 or 4 stages, depending on the mission objective. In this case we can find 4 boosters with a mass of 41.1 tons, an height of 16.1 meters and a diameter of 2.3 meters. Each booster has a liquid engine with a thrust of 7 MN at sea level. The burn time is 140 seconds. Then we have the center first stage with a mass of 186.2 tons, an height of 24.8 meters and a diameter of 3.4 meters. This one has 4 engines, again liquid, with a total thrust of 2.9 MN at sea level. The burn time is 158 seconds. After the separation of the boosters and the main stage, we can find the second stage. It has a mass of 49.4 tons, an height of 12.9 meters and a diameter of 3 meters. This one has only one engine, liquid, with a thrust of 742 kN in vacuum. The burn time is 185 seconds. The third stage has a mass of 21 tons, an height of 12.4 meters and a diameter of 3 meters. This one has 2 engines, liquid, with a thrust of 167.2 kN in vacuum. The burn time is 478 seconds. Then we have a fourth stage optional, with another one engine, liquid, and a thrust of 7.5 kN in vacuum. This one is needed for very precise missions where you need the payload dislocated in a really precise position. At the 8th spot we can find another China rocket, the Long March 7. It had the first launch in 2016 and the latest one in 2020, with 3 total launches, 2 success and 1 failure. We don't know the cost of H launch for this one, but we know that it can reach a payload of 13,500 kg in a low Earth orbit or 7,000 kg in a geostationary transfer orbit. The launcher has a weight of 597 tons, an height of 53.1 or 60.1 meters depending on the version, a diameter of 3.4 meters, a width of 8 meters, and it can have 2 or 3 stages. We have 4 boosters with an height of 27 meters, a diameter of 2.3 meters, and each booster has an engine, liquid, with a thrust of 1.2 MN at sea level and 1.3 MN in vacuum, and a burn time of 335 seconds. The main core stage has an height of 28 meters, a diameter of 3.4 meters, 2 engines, liquid, with a thrust of 2.4 MN at sea level and 2.7 MN in vacuum. The burn time is also for this one 335 seconds, so they separate all simultaneously. The second stage has an height of 14 meters, a diameter of 3.4 meters, and 4 engines, liquid, with a thrust of 706 kN in vacuum. The burn time is 342 seconds. The third stage is optional and it has a mass of 21 tons, an height of 12.4 meters, a diameter of 3 meters. Also this one has 2 engines, liquid, with a thrust of 167.2 kN in vacuum. The burn time is 478 seconds. Then at the end we can find the fairings for the payload. They have an height of 12 meters and a diameter of 3.4 meters. At the 7th spot we can find the Atlas V from United States. It was first launched in 2002 and the latest launch in 2020. With 85 total launches, 84 were a success and just one a partial failure. So this is one of the most reliable rockets in the world. We have a cost of 110 million per launch, with a maximum payload of 20,520 kg in a low Earth orbit, 8,900 kg in a geostationary transfer orbit, and 3,900 kg to Mars. The launcher has a weight of 590 tons, an height of 58.3 meters, a diameter of 3.8 meters and a width of 7 meters. For this one we can find 2 stages. Depending on the cargo we can have a maximum of 5 boosters, with a mass of 49.3 tons, an height of 20.1 meters and a diameter of 1.6 meters. Each booster has one engine, solid, with a thrust of 1.7 MN at sea level. The burn time is 94 seconds. The first core stage has a mass of 305.1 tons, an height of 32.5 meters, a diameter of 3.8 meters, and one engine, this time liquid, with a thrust of 3.8 MN at sea level and 4.2 MN in vacuum. The burn time is 253 seconds. The second stage has a weight of 23.1 tons, an height of 12.7 meters, a diameter of 3 meters, and 1 or 2 engines, depending on the version, liquid, with a thrust of 99.2 kN in vacuum. The burn time is 842 seconds. Then at the end we can find the fairings for the payload with an height of 20.7 meters, 23.4 meters, 26.5 meters, depending on the fairing adopted. The diameter is always the same, 5.4 meters. At the 6th spot we can find the Ariane 5 from Europe. It was first launched in 2002 and the latest launch in 2020. With 76 total launches, 74 were a success, then we had one failure and one partial failure. Each launch has a cost of $185 million, with a maximum payload of 21,000 kg in a low Earth orbit or 10,865 kg in a geostationary transfer orbit. The launcher has a weight of 777 tons, an height of 52 meters, a diameter of 5.4 meters and a width of 11.5 meters. Also this one has only 2 stages plus the boosters. In fact we have 2 boosters with a mass of 273 tons, an height of 31.6 meters and a diameter of 3 meters. Each booster has one engine, solid, with a thrust of 7 MN at sea level. The burn time is 140 seconds. The first core stage has a mass of 184.7 tons, an height of 23.8 meters and a diameter of 5.4 meters. It has one Vulcan 2 liquid engine with a thrust of 960 kN at sea level and 1.4 MN in vacuum. The burn time is 540 seconds. The second stage has a mass of 19.4 tons, an height of 4.7 meters and a diameter of 5.4 meters. We have one engine, liquid, with a thrust of 67 kN in vacuum. The burn time is 945 seconds. Then at the end we can find the fairings for the payload with an height of 20 meters and a diameter of 5.4 meters. At the number 5 we can find the Falcon 9 from United States. It was first launched in 2010 with the latest launch in 2020, with 100 total launches, with 98 success and 2 failures. Each launch can have a cost of $50 million or $62 million. Why we have 2 prices? Because this is the only rocket in this moment that can land again on the Earth after the launch. Actually not the whole rocket, but just the first stage. So if you want to recover the first stage, of course the price is lower. If you have to lose the first stage because you need more power and you can't save the fuel for the landing, of course the cost is higher. It's the same for the payload. If you want to use the whole power of the rocket, you can achieve a Niger orbit, but of course the price is higher because you can't land again the first stage. In this case we can have 2 payloads, 22,800 kilograms if is expendable and 15,600 kilograms if reusable in a low Earth orbit, 8,300 kilograms in a geostationary transfer orbit if you want to lose the rocket, or 5,500 kilograms if you want to save the rocket, and 4,000 kilograms to Mars. In this case you can't land the rocket again. The launcher has a mass of 549 tons with an height of 70 meters and a diameter of 3.7 meters, and it's only 2 stages. The first core stage has a mass of 433.1 tons with an height of 42.6 meters and a diameter of 3.7 meters. It has 9 engines, liquid, with a thrust of 7.6 MN at sea level and 8.2 MN in vacuum. The burn time is 162 seconds. This one is the stage that can actually land again on the Earth and can be adopted for future launches. The second stage has a mass of 1011.5 tons, an height of 12.6 meters and a diameter of 3.7 meters. This one has only one engine, liquid, with a thrust of 934 kN in vacuum. The burn time is 397 seconds. Then at the end we can have all the fairings with the payload. They have a mass of 1.7 tons, an height of 13.2 meters and a diameter of 5.2 meters, or we can also have a spaceship with the crew. In fact, this is the only American rocket that can launch a crew into space in this moment, and just from this year. The stage is called Crew Dragon. It can have a crew from 2 to a maximum of 7 people. It has a mass of 15 tons, an height of 8.1 meters, a diameter of 4 meters and an internal volume of 37 cube meters. It can also transport a payload of 6,000 kilograms. At the 4th spot we can find the Proton M from Russia. It had the first launch in 2001 with the latest one in 2020. With 111 total launches, 100 of them were a success. We had 9 failures and 2 partial failures. Each launch has a cost of $65 million with a maximum payload of 23,000 kilograms in low Earth orbit, 6,920 kilograms in geostationary transfer orbit, and 3,250 kilograms in geostationary orbit. The launcher has a mass of 705 tons, an height of 58.2 meters and a diameter of 7.4 meters. We can find 3 or 4 stages. The first stage has a mass of 458.9 tons, an height of 21.2 meters, a diameter of 7.4 meters and 6 engines, liquid, with a thrust of 10.5 MN at sea level. The burn time is 108 seconds. The second stage has a mass of 168.3 tons, an height of 17.5 meters and a diameter of 4.1 meters. This one has 3 engines of one type, the RD0210 and one engine RD0211. All of them are liquid, with a total thrust of 2.4 MN. The burn time is 206 seconds. The third stage has a mass of 50 tons with an height of 4.1 meters, a diameter of 4.1 meters, and one liquid engine with a thrust of 613.8 kN in vacuum. The burn time is 238 seconds. Then we can have the fourth stage, this one is optional, with a mass of 22.2 tons, an height of 2.6 meters and a diameter of 4 meters. For this one we can find two kinds of engines. We can find or a liquid engine S5.98M with a thrust of 19.6 kN in vacuum and a burn time of 3000 seconds, or an RD58M engine, this one liquid again, with 85 kN of thrust in vacuum and a burn time of 352 seconds. And we finally started the top 3 with the Long March 5B from China. It had the first launch in 2016 and the latest one in 2020, with 6 total launches. 5 were a success and 1 was a failure. For this one we don't have a cost per launch, but we know that it has a maximum payload of 25,000 kg in low Earth orbit, 14,400 kg in geostationary transfer orbit, and 9,400 kg to the moon. The launcher has a weight of 851.8 tons, an height of 56.9 meters, a diameter of 5 meters, and a width of 12 meters. For this one we have 2 stages. For this one we first have 4 boosters with a mass of 155.7 tons, an height of 27.6 meters and a diameter of 3.4 meters. Each booster has 2 engines, liquid, with a thrust of 2.4 MN at sea level and 2.7 MN in vacuum. The burn time is 173 seconds. The first core stage has a mass of 175.6 tons, an height of 33.2 meters and a diameter of 5 meters. It has 2 engines, liquid, with a thrust of 1 MN at sea level and 1.4 MN in vacuum. The burn time is 492 seconds. The second stage has a mass of 25 tons, an height of 11.5 meters and a diameter of 5 meters. This one has 2 engines, liquid, with a thrust of 176.5 kN in vacuum. The burn time is 700 seconds. Then we can find a third stage, optional, with a diameter of 3.8 meters, 2 engines, liquid, with a thrust of 6.5 kN in vacuum and a burn time of 1105 seconds, or we can find also for this one a spaceship, the Shin Yi Dai Zairen, with a crew from 2 to a maximum of 7 people, a mass of 23 tons, an height of 8.8 meters, a diameter of 4.5 meters and an internal volume of 13 cube meters. It can also transport a payload of 4000 kilograms. At the second spot we can find the Delta IV Heavy from United States. We had the first launch of this rocket in 2004 with the latest one in 2019. With 11 total launches, 10 were a success and 1 a partial failure. Each launch has a cost of $350 million, with a maximum payload of 28,790 kg in low Earth orbit, 14,220 kg in geostationary transfer orbit, or 8,000 kg to Mars. The launcher has a mass of 733 tons, an height of 72 meters and a diameter of 5 meters, with a width of 15 meters. And for this rocket we have 2 stages. We first start with 2 boosters. They have a mass of 226.4 tons, an height of 40.8 meters, a diameter of 5.1 meters, and each booster has an engine, liquid, with a thrust of 3.1 MN at sea level. The burn time is 242 seconds. Then we have the first core stage, with a mass of 226.4 tons, an height of 40.8 meters, a diameter of 5.1 meters and a liquid engine with a thrust of 3.1 MN at sea level. The burn time is 328 seconds. As you may notice, the main stage and the 2 boosters are the same. They have the same dimensions, the same engine. The only difference is the burn time that is a little longer on the first stage. The second stage has a mass of 30.7 tons, an height of 13.7 meters and a diameter of 5.1 meters. This one has 1 engine, liquid, with a thrust of 110 kN in vacuum. The burn time is 1125 seconds. Then at the end we can find the fairings for the payload with an height of 14.3 meters or 19.1 meters depending on the payload and a diameter of 5 meters. Also for this one we can find also another choice, a spaceship. This one is the Orion in development in this moment. It can have a crew from 2 to 6 people with a mass of 15.5 tons, an height of 3.3 meters, a diameter of 5 meters and an internal volume of 20 cube meters. It can also transport a payload of 100 kilograms. And at the end of the list, at the first spot we have the Falcon Heavy from United States. It was launched for the first time in 2018 and we had the latest launch in 2019, with 3 total launches, all successful. The cost also for this one can be $90 million if you want to use again the rockets, the first stages, or $150 million if we need the full power and we can't recover the first stages. And it's the same for the payload, we can have a maximum payload of 63,800 kilograms in low Earth orbit, or from 30 to 57,000 kilograms if we want to recover the first stages, 26,700 kilograms for geostationary transfer orbit, or from 8 to 10,000 kilograms if we want to recover the first stages, and 16,800 kilograms to Mars. In this case we can't recover the first stages. The launcher has a mass of 1,421 tons, an height of 70 meters, a diameter of 3.7 meters and a width of 12.2 meters, with 2 stages. For this launcher, the boosters are actually other 2 Falcon 9 rockets, the same we have seen before, so we can find 3 of them, 2 work as boosters and 1 as main stage. But let's check them again. The 2 boosters have a mass of 431.1 tons, an height of 42.6 meters and a diameter of 3.7 meters. Each booster has 9 engines, liquid, with a thrust of 7.6 meganewtons at sea level and 8.2 meganewtons in vacuum. The burn time is 154 seconds. The main stage in the center is another Falcon 9, so we have the exact same specifications. The only difference is the burn time, that here is a little longer, 187 seconds. The second stage has a mass of 111.5 tons, an height of 12.6 meters and a diameter of 3.7 meters. This one has only one liquid engine with a thrust of 934 kilonewtons in vacuum. The burn time is 397 seconds. At the end, on the top we can find the fairings with the payload, with a mass of 1.7 tons, an height of 13.2 meters and a diameter of 5.2 meters. So as you have may noticed, the Falcon Heavy is made by 3 Falcon 9s connected together. This is why the informations are exactly the same of the Falcon 9. Of course, 3 of them together have a lot of more power. This is the most powerful launcher we have in this moment. There are others in development in the future, but in this moment this is the most powerful we have. And also this list is finished. I know we have so many rockets that we didn't mention in the video, but don't worry, in the future I would like to make the same video, but with rockets still in development in this moment that are even more powerful than the Falcon Heavy, but also the opposite, rockets less powerful than the one present in this video, but that really deserve to be mentioned. So let me know in the comments if you like the idea. Of course, if you liked this video, please leave a thumbs up, that is always appreciated and helps the channel. Remember that you can find more videos like this one clicking in the right up corner in the description of the video, or simply going in the channel page. You can find a playlist that will help you to find this kind of videos. And as always, see you again every Saturday at 1 PM GMT Greenwich Main Time for a new video. Bye bye!